Okay, let's go for today's experiment. It's gonna be double-slit interference. In this experiment, we are dealing with three different types of slits, right? Distances. Let's go to the introduction for the theory. Okay, remember we have the double slit and we have interference on a screen at a distance L, right? And the formula is given by lambda, right, is equals to d, the distance between the two slits, times y, right, the distance from 0, right, to any point on the screen, correct? M, the order number, right, and L is this distance, right, between the screen and the slit and the screen. Perfect. Remember, this is a screen. This is the screen right here. Great. Okay, we are looking for the distance between two fringes. To do that, because the fringes are gonna be very close, and it's hard to see, right? Exactly, right? The distance between two fringes. Let's do it this way. Let's take several fringes, like in this case, from 0 to 7, right? So we have 7 fringes. Let's measure the distance, right, for these 7 fringes, and then let's divide that distance by the number of fringes, like in this case, right? For example, let's take 7 fringes. Remember, we start from 0. The first one is 0. The fringes could be dark or bright. Okay, 0, 1, 2, 3, to 7. Perfect. Now that's the distance. Okay, now let's divide that distance by the number of fringes. In this case, for an example, it's going to be 15 centimeters divided by 7. Well, y means the distance between two fringes is going to be 2.14. If we're looking for distance between two fringes, right? Like in this case, m is going to be equals 1. Okay, in this formula. Perfect. Now, we have 3 cases, right? When the distance between the slit is 0.25, well, let's try to find n, right? The numbers of fringes that we want to use is up to you, right? Now let's measure the distance and let's find y, right? In this way, right? D divided by n. Perfect. Now let's go to the experiment, right? Data. In the experiment data, we have actually this gonna be dy over L, correct? That's from the experiment, because from the theory, the wavelength, right, of the laser is about 632.8 nanometers. Okay, perfect. So let's substitute this value right here, right? Show the values, correct, for the experimental wavelength, and then find the percent error. Great. Let's go to the next one. We're going to change, right, the distance between the slits. It's going to be 0.50 millimeters, correct? And the same thing, take the number of fringes. It's up to you. You want to use 5, 6, 10. It's up to you, correct? Find the distance, divide the distance by n, and we get y, right? We get y, and then using the same formula from here, right? Plug the formulas right here, find the values, and find the percent, correct? Let's do the same thing for the third one, right? Repeat the steps, and this is gonna be today's experiment, right? Again, this is theoretical value, right? This is L, everything is given for you, correct? And now I'm gonna show you pictures, right? Pictures that give us these 3 cases, right? In these 3 cases, I'm gonna show you, right, the interference is gonna be like that. Hopefully you're gonna get it, because it's gonna be moving a little bit to adjust it, to adjust the best, to get the best picture. So once you get the best picture, please freeze the picture, and then zoom in, right, to see the numbers of fringes that you want to use, and to see the distance that you want to use too. Okay, perfect. See you right later for the pictures.